Okay, we're beginning with division of radicals, and it's kind of a complicated story. We'll get to it in just a minute. But first of all, a fraction is division. This is still division, even though it's not written with the division sign. So we begin with this. The first thing to do is just simplify. And so we're breaking down the square root of 54. You could do, they're doing the perfect square method, but we get this. 3 square root of 6 over 6. Now, like we've always said, I like that they're doing it like this. So if you notice what they're doing, when we break down a fraction, I probably showed you this before, but like if we had 2 over 4, we say, oh, that reduces to 1/2 because you could divide 2 into each of them. Well, what you're really doing is you are dividing out the common factor that they share, and you're left with 1 over 2. Well, that's what I like they're doing here. 6 is really 3 times 2, and we're slashing out the common factor, and we would get just the square root of 6 over 2. So what we're beginning with is to divide. We're going to just simplify and divide and reduce, essentially. So let's break down 32. I'm going to do the old school method here. Breaking down 32. Okay, so 32 is made up of a bunch of 2's. All right, so we're going to pair those up. I can pull out a 2 there and a 2 there. I get 4 square root of 2. Okay, so now we've got 4 square root of 2 over 8. Well, we can just reduce this. Now, you don't have to do this. I'm sure you could see, if it was just 4 over 8, how would you reduce it? But I'm just going to show you one more time that what's really going on here is that we can cancel the matching factors, and we'd get the square root of 2 over 2. You knew that, though, probably. 4 over 8, if you just reduce the fraction part of this, you'd get 1 over 2. Same thing. Now, we can't cancel the radical part. There's nothing to match with, but okay, this top is going to break down to 5 square roots of 3 over 15. Now you could cancel the matching factor, that's really what you're doing, but if you're thinking, okay, 5 over 15, well, that reduces to be 1 over 5, and I don't really need to show the 1 there. Oh, I'm sorry, no it doesn't. It breaks down to be over 3. All right, now this gets a little different. We've seen this idea before. First of all, let's let them, oh, they did it all at once. Let me do this. So, let's see. Okay. Now, if I've just reduced the square root of 24, and this is what I get. So this is nothing new. Now, do you remember that if we want to divide something into both of these, we have to be able to cancel it into both? Actually, let me show you. So you could see that I could divide a 2 into everything here and reduce it, but I think the way they're doing it is better. Let me show you what they're doing. I've pulled a GCF out of the top. You see I pulled out a 2, and on the bottom, I'm going to make the factors there. That's supposed to be a 6. Okay, I pull that 2 out, and now this is factored on the top. And if you have factors, you can cancel matching factors. And so I'm left with 3 minus the square root of 6 over 6. Now, this 3 and the 6, they do not cancel. Because of the minus, you have to cancel into the entire thing. You either have to go into the 3 and this, and you can't. So what I always like in this too is, suppose you were trying to find the equation for a line. You divided both sides by 2. Well, the 2 has to be able to go into him and him. So he can do it, and you get this. But if he can't go into both, you can't simplify it any further. And that's what's going on here. So let me show another one of these. So first of all, we're going to simplify that top. Okay, now I think they're right about, if you really want to understand, we're going to, let's factor this. Let's pull out a GCF of a 2. Now, Well, let's go ahead and write it like that while we're just getting the hang of this. This is 2 times 5. So this is factored on the top, this is factored on the bottom. You can cancel that matching factor. And I'm left with 4 minus the square root of 10 over 5. Let's do another one here. 3. Okay, let's pull out the matching factor. Let's factor this. It is not factored because it has a minus in the middle, so let's factor it. Now, if you see this without having to do all of that, it's fine, but I'm going to show you this. I can now factor the top, factor the bottom. I can now cancel the factors, the matching factors. That's what reducing is. Now, this 4 cannot go with that 2. He'd have to go into both, and he can't. So we're done. Okay. We are now going to use a trick. Yeah, I wonder where they were going with this. Okay, so, well, let me just show you what there's. If we have square roots over top of each other, so here's what I want to say. These two things are identical. We can either take the square roots of the top and the bottom individually, or we can square root the fraction, and it gets the same thing. And we can go between these anytime we want if it's useful to us. Now, the reason this would be useful to switch over here is now if I have a fraction underneath that one radical sign, I can just simplify it. So they notice that there's a common term. They each have a factor of 3, so they just reduced it. Now, they brought it together in order to reduce it. Now, actually, I don't like the way they're going there. Now, let's take it back apart and make it the square root of 9 over the square root of 25. So we've just going back and forth between that whenever it's to our advantage. And the reason it's to our advantage is because the square root of 9 we know, and the square root of 25 we know, and we're done. Okay, let's do the same thing. We're going to put this back together as just one root. And the reason we're going to do that is we can reduce this. These are both divisible by 2. So you could show all the factors if you wanted to. Maybe it's even more than that. Yeah, it's even more than that. So I took a 4 out of, or a 2 out of both of these, and I get 24 over 54. Now they're both even again. I'm going to do it again. I get 12 over 27. You know, I'm going to do, well, you could do it again. So I am going down one individual at a time, but I think this is taking too long. I'm going to break each number down. Okay, here's what I'm getting at. So I'm going to put all the pieces here. Okay, now I've factored both of them inside of there, so I can just cancel out all the matching factors in one shot. Okay, when I do that, do you see I'm left with 4 on the top over 9 on the bottom? Just multiply those back. Now, let's use our trick again. You could already do this if you see where this is going, but it's also the same as breaking them into the individual ones. And I've got 2 over 3. Okay. I'm going to try to just 3 goes into both of these. Let's see if that's good enough. So I'm going to put them back together and divide a 3 into each of them, and I should get yeah, it still breaks down. So you could do what I did in the last one. I'm just reducing one step at a time in this one. Now these are both divisible by 2. Okay, now this is where we're going. So if I had broken it all down and canceled all the matching factors, I would have got to the same place. I get square root of 16 over 9. We could do that as individual ones, and we'll see that we get 4/3. Okay, now here's another reason we've got I don't knows in there, but look what happens. We're going to bring this back into 1 like we did before, and now we're going to simplify. So I like how they've done this. They broke it all down, and one of the y's on the bottom would cancel with one of the y's on the top, and they're left with this. Now, we know how to simplify this. I could bring out 2y's, and I'd be done. So we're going to use this to our advantage. We're going to put it back together and then simplify. So an r will cancel. Let me write this one all the way out. That's what's on the top, and on the bottom is this. So I put it back together. Now cancel the matching factors. Now there's nothing left on the bottom but a 1, so I don't even need to show that anymore. I'm just going to show that I've got 2r². Okay, r squared lets me bring out 1r, and I would have this. Okay, we're going to put this back together under one of them. Now, you probably don't need this, but I'm going to show it to you anyway. Those match, those match. Now, you probably don't need that, but if I cancel out all the individual p's, I am left with 4 of them on the top. I'm also left, so the only thing I'm left with is 7p to the 4th. Just broke it all down. Again, you may know that you can just subtract those exponents. That's the trick. But if you want to just expand them, you can, and then you cancel out the matches. Okay, well now we're not done with this. If I have 4 p's left on the inside, I can partner them up, and I can bring out 2. Oops, no, nothing left on the inside. It would just be p squared square root of 7. Okay, just more complicated, but we're going to put it back together. Going to cancel the matching factors, and I'm left with this. Now I would have then broken this into the 2 individuals. Now the square root of the top is 2x, square root of the bottom is 3. I'm going to bring this back together. Now I'm going to do all the factors. Oh, sorry, these are s's and those are 5's. Okay, got one s on the bottom. What's 128 made up of? Excuse me. Okay, I've got them all broken down. All I can cancel is 1, 2, and a 3. So what I'm left with is, on the top I've got 25s squared. On the bottom I have 4, 8, 16, 32, 64. Now that's all underneath a square root sign. I'm going to give it to the individuals. And I can take the square root of the top, I get 5s. Square root of the bottom, I get 8. Okay, same thing here. I'm going to bring it back under one of them. Again, if you want to try this one, do it yourself and then check what I did here. Okay. I'm going to jump ahead again. I see that they're going to both be divisible by 3, so I'm going to save myself some time, and I'm left with 25, and then I'll have 4 q's left on the top. Can you see that? If I had 5 and then 1. If I divide this by 3, I get 36. Now, let's make those two individuals square roots. And I get 5q to the second over 6. Okay, I think we're almost done here, and all that's going to do is just they get more complicated. So we get a really nasty one with a's and b's, but it doesn't change anything. The idea is the same. We simplify everything down and break it into two square roots. I guess separate it back into two square roots, and that's how they came up with that. Okay, so really complicated, but we're going to put it together under one root so we can simplify. So I can cancel the 2. You could break this number down if you wanted, but I see 2 is going to go into each of them, so I'm going to have an 81 there. Now see if you can follow where I'm going with this. So I canceled a 2 at the top, I got to the 81. If I had 10 x's on the top and 6 on the bottom, I'd wind up with 4 x's on the top. On the bottom here, I've got 6 y's on the bottom, 2 on the top. If I cancel those down, I'd be left with 4 y's on the bottom. Now let's turn that into individual square roots. Okay, square root of that top. Hopefully you're comfortable seeing that would be 9x squared, and on the bottom would be y squared. Okay, try this one on your own if you want to pause the video. Same thing, just more complicated. I'm putting it back together under 1. Okay, so I'm going to deal with this. Do you see they're both divisible by 3, so I'm going to have 100 on the top. Now I have 3 m's on the top and 2 on the bottom. That's going to leave me 2 m's on the bottom. I've got 7 on the top and 1 on the bottom. That's going to leave me 6 n's on the top. Now let's turn that back into individual square roots. And I'm going to get 10 n to the third over m. Okay, now that's complicated, but I hope it wasn't too hard for you. And then we're going to learn some more tricks about dividing roots in our next video.